and Josh, like, are you buying her a dinosaur? And looked at my sister. He said, no, I'm getting it for her sister. And Josh's dad was like, oh, how old is she? And he was like, 15. I'm like, yeah. I was having a bad day and I really wanted that dinosaur. I did pay it back though. I'm not being
How much was it?
$30. It's worth every penny though.
Okay, here we go. So our essential question is, how do we apply the binomial theorem by using Pascal's triangle to expand any binomial a plus b raised to n power? And we're going to limit it up to n is less than or equal to 11, or x plus y to the n, all right? And so I loved the fact that several of y'all went and solicited assistance. I was very entertained by that. But really, let's not make it any more difficult than what it needs to be. So first and foremost, a plus b to the 0 power. Anything to the 0 power is what?
1.
So what is a plus b to the 0 power?
1.
Anything to the first power is what?
The same.
Itself, right? So that is a plus b. Now, Paul asked me, and it was a good question, a plus b to the second power is simply a plus b times a plus b. And so therefore we can simplify that by FOIL. So you got a times a is a squared. And then outer, which is a times b. A times b is plus ab. Then you've got inner, b times a,
Plus 8.
still plus ab. And then you have last, b times b. So then that equals, if we combine like terms, a squared plus, how many ab's do we have? Plus b squared. Do you agree? Well, when we get over here to a plus b to the third power, this is simply a plus b squared times a plus b. Do you agree? Because when we multiply like bases, what do we do to the exponents? Yes, we add the exponent. So what's the understood exponent on this a plus b? 1. So is this the same thing as a plus b cubed? Yeah. So to be able to multiply that, the easiest way is to multiply it like this. So we're going to go right up underneath here and say multiply by a times b. And so b squared times b. B cubed. 2ab times b.
2a squared b.
So we are multiplying 2ab by b. And that is going to give us 2ab squared. You see that? That's 2ab times another b. So your 2a is going to stay the same. Your b's are going to be squared now. And then our last one is to multiply a squared by b. And that gives us a squared b. All right, so now we have to multiply by A. We have B squared times A,
That's AB squared.
AB squared. We've got 2AB times A,
2A squared.
and then we have A squared times A.
A cubed.
Combine like terms. We've got A cubed plus 3 A squared B plus 3 AB squared plus B cubed. Now we could keep going and continue to multiply by another AB. So this is equal to A plus B cubed times A plus B.
That's a big.
Yeah, it's gonna keep growing, isn't it? So if we multiply by another A plus B, following the same logic as before, B cubed times B is B cubed times B,
It's B to the fourth.
B to the fourth.
Yeah.
And then you've got 3AB squared times B. You wanna do it and see what you get? That's a 3, George, I need to fix that.
That's a big. Yes. If you got the X. it's in the same order.
Why did the B disappear?
Because it's a fourth relationship.
Where did the B disappear?
So it's like A squared B at the top. And then it goes down. There's the B. That one's.
The A squared B combines with the 2A squared B and make 3A squared B.
And then the 2AB squared combines with the AB squared to make a 3AB squared. So we're just going through the multiplication of multiplying all the terms by B first. That's gonna be this row. And then all the terms by A, which is gonna be this row, and then we're gonna sum them up. So we have B cubed times B, which is B to the fourth. We've got 3AB working our way from right to left, 3AB squared times B, that's gonna be 3AB cubed. Then you have 3A squared B times B, and that's gonna be 3A squared B squared. Then we have A cubed times B, so that's gonna be A cubed B. Next step, multiplying all the terms by A. So if we multiply all the terms by A, we will have B cubed times A. B cubed A, right there. Then 3A B squared times A. That's gonna be 3A squared B squared. Then 3A squared B times A. It's gonna be 3A cubed B. And then your last one, A cubed times A to the fourth. Combine your like terms, you have A to the fourth plus 4A cubed B plus 6A squared B squared plus 4AB cubed plus B to the fourth. So there is several patterns embedded in this. Several patterns. One of them is the exponents. So what was it? I'll back out some. What are we raising number 5 to? We're raising it to the fourth power. What's your highest exponent?
4.
Look at the sum of the exponents on the second term, that 4A cubed B to the, what's the understood power there?
First.
So what is the sum of the two exponents?
4.
Look at the second or the third term, what's the sum of the exponents?
4.
Look at the fourth term, what is the sum of the exponents?
4.
And then the last term?
4.
There you go. So that is one of the patterns. Also, as A decreases by one exponent, what is B doing? It's increasing by one exponent. So what is the understood B on that A to the fourth term? If the exponents have to sum to 4,
We do 0.
B to the 0 power. Anything to the 0 power is. What is the understood A on that B to the 4? A to the 0. So this is several different patterns, but if you will, go ahead and look at, you should have this page in your sheet. Your Pascal's triangle, it looks like a honeycomb. It looks like a honeycomb. You just learned it? The way that we're going to construct Pascal's triangle, and the way that you can construct Pascal's triangle, this is going to give you the coefficients for expanding your binomials. I just made a mess. All right, so 1, 1, 1, 1, 1, all the way down. All the way down. 1, 1, 1, 1, 1.
No.
All right. Now, your other side. 1, All the way down.
Oh, no zeros for three.
The way that you derive is the two that are touching. So right here, you sum. So 1 plus 1 is the two that are touching. 1 plus 2 is two that are touching. 2 plus 1 is, now you've got 1 plus 3 is,
That makes so
Oh.
much sense.
I feel like I just discovered my words.
We just discovered. Ow.
Who's all? Jack, do you even know what Pascal triangle was before?
Absolutely not.
Exactly. So, look, just got
Did you?
fired. I did not.
Why fire?
No, you learn to stop
This
questions.
is the best thing. Is it's
The best thing is.
Worrying sometimes.
Absolutely. Just not.
Oh, worrying.
Yeah, I've met myself too. Myself.
Dang, that's pretty.
Yeah. Pretty self.
Absolutely. These numbers are good.
No, they're like.
Nine.
Who's the 7 and the 5?
26.
Are you getting it? I gotta take this thing out of my binder. I can't write this. Can't count it in your head. So it's just. Are you also doing 140?
Yes. Plus 405. 84 plus 36, what is it? 120. Possibly. Yes. Should be. Yes.
Gracious. Kendra, what's that? Never mind. What is 146? Yeah.
I don't think what you're doing.
136 and 136.
There's no 136. Where?
Oh, Jack, you messed
The
up.
same level as that.
Messed up.
I thought that was 126. Yeah. Whoops. I did not accept.
I'm at mathematics.
I'm doing it all in my head. There's not big shakes.
Waffle up calculator.
It's fun doing it. Then you make mistakes. Oh, stupid. Hey,
Or if you don't make mistakes, you're like.
getting a little
uh,
heavy.
Just tell me if you end with 560 on the fourth row.
Miss Harris,
Yes,
wouldn't that be 66?
yes.
84 plus 36.
What,
84 plus 36. I already did this. Hold up. I just put the. No, never mind. Not one.
too bad.
I didn't do the other side.
Oh.
Oh.
Five.
Oh,
This is, 505. That's a big one.
Is that better, guys?
Yes,
What?
ma'am.
Yes. That's 84 plus 136.
What?
Does that look better?
It's a 126.
Yep.
Oh, I thought it was 90.
Where are we at?
And shouldn't it be 91?
No, 106.
I had a 130.
That's 272.
Yeah.
Not 252.
I didn't think that's 5.
Harrison.
2 out of 2.
No, Jack.
Jack, that's actually a 126.
So I was right.
Yeah, we were wrong.
Calculators.
No, that's not what I did. That's what I did.
Oh, of course it is.
I'm
I
a
thought you did it with your calculator, that's why I put it down.
Now check me.
Yes, ma'am, I put that.
Yeah, it's a 126.
That's 595.
You keep getting.
Then what do y'all want here? 55 and 165?
That would be 65 is 220.
Yeah. Did that one.
I did that.
This is 495.
250.
That would be. Oh, see, I didn't put there.
4.
Six.
It was just a little bit.
Hold up, that's 595, not 495.
4.
595.
Yeah.
That's fine.
Wait, how did it find?
Yeah, it's should be
It's
495.
495.
Wait. But 165 plus.
30.
Bingo.
What?
5.
What are y'all talking about?
1.
Doesn't matter.
What? My world's crumbling around the table.
For the large numbers
What's wrong?
necessary.
What's going on?
Jared, would that be 210? Oh, it is 2.
That's right.
That's a thousand.
I think I have a.
In famous words of some kid from the middle school soccer team a few years ago, Tanner, someday someone's gonna.
Yeah, probably.
Jack, do you remember Clay?
Oh, Clay?
Yeah.
Yeah.
He told me that someday someone was gonna come through. So funny. 3:30.
What is 15 plus 66?
Is that right, guys?
Yeah, I got
What?
Okay.
What? No, good, okay. Yeah, that was a joke. Marty, yes.
That would be a lot, so it's been.
get through.
3. That's what happens when you do it in your head.
So far, so good. I've only messed up. Once. Eight. One. They're 12 and 7.
Yes.
Yes, so I did that right. That's good. It's really hard to see. 18, 16. It's like something famous happened.
All right, who has the rest?
Yeah.
I'm tired of adding.
I figured out a new way to add them, so I don't mess up. Instead of going left to right or right to left.
So you know in reverse of how you're supposed to read it.
6 plus 5 is 11, so I add the 1 to that 8, that means that 0, adding the 2, 10, which makes it 1, 0, 0. Put it.
Are we gonna have to do numbers like this?
Yeah.
6, 4, 9, 5.
Oh. I get those as figures.
I'm never going to fool that time.
Sure. Oh. Well. That's 5, 6. What?
11, 440. And then 12,870. This is
It is. It's kind of like a normal triangle, but bigger.
It's usually what I get triangle is. And bigger.
That's good.
560 or
I feel like I'm just going.
Okay,
Yes.
560, 18, 20.
yes, it is. See, and y'all are at a disadvantage because I can blow mine up. And write.
Oh.
You want me to go back up? All right, I'm gonna show you how it works, and I'm also gonna show you how to label. So I'm giving you just a few more minutes.
That's a lot more.
That is a lot of numbers, isn't it?
This is.
After this, we have division, and that's it.
Wait, we have another one of these to do?
No,
Oh. Why is there a?
I did.
Oh.
all right. Pencils down when you have all of it filled out. That way I know we can proceed.
Hey, that was. If you don't have.
Still don't understand.
Those are the coefficients, so like when you say we have a square equals two AB minus b squared, that's the two at the top.
All right. Close? Okay.
Which I think is around
11. So guys, I'm gonna flip back and forth. Not like that, I'm not. I'm gonna flip back and forth between. Between our bell ringer and the Pascal's triangle. So go back to your bell ringer.
There is. Why is there another Pascal triangle? Facebook lose this one?
Challenges of copying when I'm piecing things together. Quit.
So in other words, activate
Yes. So if we go back to our bell ringer and we look at it, and have your Pascal's triangle handy. On the top row, what is the single number on the Pascal's triangle? 1. So that means that our row are labeled in this manner. Row 0. When you raise a binomial to the 0 power, it equals 1. Now let's look at our coefficients on when we raise it to the first power. We raise it to the first power. What were our coefficients of the A and the B term? 1. So then what are our coefficients when we raise it to the second power? It's this line right here. So we have A squared B
1, 2, 1.
plus 2AB plus 2AB, yes. Plus B cubed. So that's 1, 2, 1. What row is that?
That's row 2.
What are our coefficients on A plus B cubed?
One, three, three, one.
Do you see the pattern? So when we are expanding by Pascal's triangle, we can use the triangle to find our coefficients and then multiply it by everything else. Okay. So we're gonna practice that, but I figure y'all need a brain break. Do y'all need a brain break? Okay. So let's put our phones on our desks. Who's gonna drive the train? Who can drive without running stop signs?
We
Always stop.
When you're not driving illegally.
Hey, I don't drive illegally anymore. I only, it was rare times that I would drive, get out of.
Oh, yeah, it was rare times.
The interstate?
Yeah.
On the interstate.
Stop at the end of the hall.
But you know that. I like to go, but
tell me.
Like, it's, when I left,
I wanted to give it obviously for the job that
So what does this mean with expanding binomials? Exactly what does it mean? So if we go to, let's look at, it's fourth block, I need first block. There we go. Page 7 in your packet. How do we apply this? Well, we know we can very easily complete our Pascal's triangle because we did one that was a lot more intensive, right? Just go into row 5. Hey, we can handle that. So then we have 1, 2, 3, 4, 5. Actually, what you could have done is just count it all the way down instead of added 4 and 5. And then we know 3 plus 3 is 6. So that's just up to row 5. On our essential question, what did it say we were going to have to go to? 11. So less than 11. So that means 10, row 10 is the highest that you'll be responsible for. All right. Highest you'll be responsible for. So what does this mean about expanding this binomial a plus b cubed? Well, we did that during our warm up. And we know that our coefficients, if we're cubing it, what row are we going to? Row 3. Because we start with row what? 0. Anything to the 0 power is 1. Anything to the first power is itself, right? So if we go to row 3, then we know that our coefficients are going to be 1, 3, 3, 1. We know also that we're going to start with a to the what power? A3, B0, A2, B1, A1, B2, and then A0, B3. Because the sum of our exponents always has to equal whatever power we're raising it to. So then to finish it up and write it out, you've got a cubed plus 3a squared b plus 3ab squared plus b cubed. Isn't it though? Isn't it though? So what about it is your coefficient?
Oh,
That's just your binomial theorem in scientific terms, scientific notation, but we're going to look at number 1. What about a plus b raised to the 5th power? What row are we going to?
row 5.
So we're going to row 5.
Do we have to know the that?
This right here?
Yeah.
No,
Thanks.
I need you to know how to use Pascal's triangle. You don't have to memorize the theorem. If we're going to row 5, what are my coefficients?
1, 5, 10, 10, 5, 1.
1, 5, 10, 10, 5, 1. Then I'm gonna put in my A's and B's. So it's A to the 5th, A to the 4th, A cubed, A squared, A, and then B to the 1st, B squared, B cubed, B to the 4th, B to the 5th. Write it all out.
So you just like. Just like.
As long as it's bigger, it's small.
You just start with the biggest one, slowly.
Yeah,
It's not like- But so as you go like left to right with the like A just like moves down 5.
from 5 to 0.
Oh,
Because on that B to the 5th term, Paul, what is your A?
0.
So it goes from 5 to 0.
So basically, they're just opposites going in the other direction. Okay.
A goes down, B goes up.
More sense now. And then when you write the final answer, you just add the like term.
Well, when we're expanding using Pascal's triangle, you're not gonna have like terms because
Oh, yeah.
your expansion does that for you.
So that's just the answer.
This is it. Okay. That's it. Yes, that would. Y'all do 2 and 3.
2 is big.
Y'all do 2 and 3.
Well, the triangles helps. Writing it out.
So long.
Writing it out.
Like this cramp over here.
There's that.
Please.
C to the 7, C to the 3rd.
Aw, Haley.
Was 212, number 3 is star, to the 10th.
You know the cool thing, you guys wanna know something cool?
Yeah, we kind of.
Each time the exponents add up to 7.
See my scratch papers, I had to do one.
That's not,
Yes, each time the exponents add up to.
yeah, we already knew that.
Look, if you're gonna make me feel stupid.
You already said that.
No shit. You're. I was.
Okay, so I got, so I got it.
I'm having two lines to write. Wait, can't that
Yeah.
never happens in the equation?
Here's
That's
your.
not-
No.
45, C for the second.
852. Oh, I'm writing this as A and B.
17.
Actually, I'll fix that.
What'd you do? Yeah, what'd you do?
I'm writing this A and B as C and B.
Oh,
Okay.
That took 2 full lines of writing.
Yeah.
That is absolutely terrible.
6. All right, here we go.
I mean, you still could have nobody having to work it out, like, work it out.
Yeah.
you know.
be happy we just have to write it. Are you sure? And that C doesn't equal something.
Guess what? The next one. She does.
Oh, shoot.
What the heck? Whoa. Whoa. What's going on?
It's a
I don't know.
No, you don't have to do that. That's the
So amazing.
creative work.
Number 3. I had to do 2 lines.
That's what this one over here is complaining about. 2 whole lines of writing.
This is like that stuff for Dr.
What
Baylor.
equation? That's pretty.
Oh, that
Okay, look,
electron
on
configuration.
10,
Oh, my God.
That's the
on 10, there's not 1, 2, 3, 4, 5, 6. What did I miss?
You're always gonna have one more term than what you're raising it to. So if you're raising it to the 10th power, you need 11 terms. If you're raising it to the 7th power, you need 8 terms. You'll always have one more term than the power you're raising it to.
On our test, is there gonna be more stuff to learn?
No, I have.
So if you're raising it to the 7th, your final number should have 8 terms.
Which number did I not?
She's probably.
No, I'm missing a number.
No.
No, because C is to the second. If I put a 1, it'll be C. If there's 11 turns.
0.
So on your test, is there gonna be more stuff
I see.
to learn? Yes, you're going to be classifying, so those videos I told you you'd be watching tonight instead of homework. You'll be watching those, you'll be classifying based upon the term. So constant, linear, quadratic, cubic, quartic, quintic, and then monomial, binomial, trinomial, polynomial, constant, all that. And then adding and subtracting polynomials, multiplying polynomials. And what we're gonna do after this is divide polynomials.
I was over here freaking out.
Oh, wait, you don't. 243 times 3.
So how goes it back there?
We're great.
I'm good at.
We're slow. Boom. Give me some numbers for C. I mean, C and D. Let's put some numbers.
Grayson, how's it?
How goes it?
Then do row 16.
Your whole team?
Elijah? Good or bad?
Whole team? All right.
The next one does involve more.
So what happens, up until now, your coefficients have always been 1. So we could just pick up the coefficients from the triangle. I'm assuming y'all have compared with your team, so you know that you have the right answers.
You have the right answers. I got.
I know how to
10 right.
I'm a little concerned about what you're saying.
Well, I get what he's saying. That's not right.
He's listing the exponents of C.
Oh.
That's what he's doing.
Okay,
I'll word them in weird ways.
so Tanner, will you write out number 2 for us?
I can't do it. Just so that.
Take a look, check your work, check your work.
Oh, Josh.
Abstract.
That's what I got. I'm in for that.
Why? Because you have to.
Cause
Oh.
you just go, what, we go to row 7,
Or
7, we look quick.
Fixing the mistake, the variables.
The first one, it's.
Wait, did you?
7?
No,
X,
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 X.
X, X, 4, X, X, X.
Oh, I was testing.
And then
Don't
Y,
worry, I did too. I
start
just
up here,
figured out the change.
that's
While Tanner's writing, what road in our Pascal triangle that we derived end at?
16.
Do you think Pascal's triangle really ends at 16?
No.
I'm not there.
You know, it'd be
And if it never ends, what do we call that? Infinite. It goes on to infinity.
It's being Jack, think alike.
Check your work, check your work.
Okay, Tanner, let's
I don't know.
Gotta see.
Peter, why would you write X and Y? You put A and B because of X and Y. Just why do you stick with it?
I only see one thing missing.
Because it's X.
On the
pluses.
pluses.
Yes. Let's put the pluses in, the addition sign.
That's one big string.
That's one part of the.
Yeah.
Oh,
Otherwise, that is the equivalent of a run-on sentence in math.
pretty
And
much.
then you have to multiply it all.
Yes, absolutely.
Make that
You
next.
multiply that.
Do you want to talk about something that's a nightmare? All right, Miss Sid, did you say you wanted to do number 3?
Oh,
All right. Here you go, number 3. Take a look, check your work, check your work. That is my goal today. Yes, dear.
So, I sent you a picture of my, when it crashed. Well, I tried to work up and finish that, response question, but it was close, so I couldn't see the questions.
Okay.
I'll
I'll,
just have that written response.
I'll figure out something and send you an email on the third block.
Something that you can see if that's.
Yeah, I should have to do it. Your teacher will be notified. Website that.
I forgot to send them a picture of my scratch paper. And then I
Paul?
did. First, I could put some, I always have to call 15 minutes worth of oversight. Pretty deep. Is like test thing almost.
He always says, like, hard. He's been doing some stuff.
All right, check it out, guys.
Like work wise, not.
I don't know anything about it.
Do y'all agree?
Yes.
I know it gets.
So what happens, what happens when you do have something other than a +1 as your coefficients?
It gets messy.
Well, we know that we're going to the 6th row on the triangle, correct? So what are our coefficients for that row?
1, 6, 15, 20, 56.
1, 6, 15, 20, 15. 6, and then 1.
Oh, I wrote it on the wrong.
So now I'm gonna put in a bracket.
One.
No, that's fine.
And then I will put in a bracket for your second term.
That's
Make sure we don't need that one. All right, so now let's fill in where we need to fill in. We have x to the 6th power. We have x to the 5th power, -3 to the 1st. X to the 4th power, -3 to the 2nd. X to the 3rd power, -3 to the cubed. X to the 2nd power, -3 to the 4th power. X to the 1st power, -3 to the 5th power. And then your x drops out because it's x to the 0, and you've got -3 to the 6th power. Why does it matter? Because when you raise a negative number to an even exponent, it is a positive number. When you raise a negative number to an odd exponent, it is a negative number. So therefore, bringing it out, you have x 6th power. Then you have -3 to the 1st power, so that's -3. Multiply it by 6. -3 times 6 is -18 x to the 5th.
So.
-3 squared. +9. +9 times 15. X to the 4th. -3 cubed. -27 times 240. 20.
Oh, negative 20 times birds.
Negative.
27 is -5.
-3 to the 4th power. And then 81 times 15. -3 to the 5th power. 243 times 6. Positive or negative? And then finally, -3 to the 6th power. Positive or negative?
Oops, so that's-
better than multiplying it using any other method 6 times, right?
No, yeah.
It is still long, but it's shorter than 2-hour long
It's
problem.
shorter than the other options.
Yes. So then when we do number 5, our brackets are gonna be around the 2M and the N. Remember, in number 5, your A is 2M, so you have to square or raise not only the M to the power, but also the coefficient in front of the M. What do I mean by that?
You have to do like, if you have 2 M, since to the second, you have to do 2 times 2.
Yeah.
4 M.
Exactly. See, guys, what I want you to do is I want you to complete number 5. I'm gonna put the answer up for it so you can check your work after you've had an opportunity to complete it. And then your ticket out the door today. Your ticket out the door today is to create instructions on how to solve this. So you're gonna give me step by step how to solve.
Do we have a calculator?
Yes.
So I use it on my phone.
I'm saying 2 to 7. If there's an example.
Okay. This is your exit ticket. Make sure you write your essential question, and I'm gonna put it back up as your concept / subject. Don't forget to put your name on it and date it. Remember, Harrison, or named, clock. Harrison, and this is exit ticket. Either one, so it can be M and N, or it can be X and Y, either one.
I can't write it, she has one.
So I can cycle. No, you do that. Yeah, based on. It's hard to get it to square.
Oh,
No.
you can't just say the 7th, you gotta.
No. See that as Y.
Oh. So she knows.
Maybe.
Can't do like long form and stuff.
And what's his number?
Actually,
Sure. Always gonna help you.
I mean, you can't print this one. Write out a formula.
Oh, wait.
Oh, I need to watch that.
Yeah, what is? It does work, okay.
Oh, I got it. So- Wait, more fire. I did that wrong. Yeah, let's do this. What's that times 7? Four. Or 2 to the 6. 2 to the 6. 148. You never did. Okay, that's the first one. Okay, what is 2 to the 7?
I do.
128 to the 7.
Yes, ma'am.
What do y'all think? What's due to that?
Hey,
Times 21.
no, just your local self.
Okay.
All right, thank you. Bye.
Page 672.
672. Great.
Oh,
Can you just use
so this one's wrong. Right? No, wait,
So,
I'm freaking out.
so.
So it'd be